This is an introduction to working model simulation software from Design Simulation in Canton, Michigan. I always start by from View and Workspace, turning on the ruler, the grid lines, and X-Y axis. This way you can be rigorous, systematic about the location of the bodies relative to the XY plane. So origin here and x-axis to the horizontal to the right. What's shown here, the full screen in white, is the ground link, and you can connect to the ground link as well as bodies between themselves. So for example, the bodies that I have available, and by the way, you can do import from AutoCAD via the DXF format, and that will be for polylines. So I can create and edit their location, X and Y location, that being of their center of mass or centroid, and their geometry, main geometry. So I have radius of 0.7, I can make it 0.5. Same I can do if I open the geometry function. So here it says center of mass and radius, and double click or click on the body and open properties. You see here their location. We were able to modify it from the corner of the work window, as well as the angle. So I can say pi over 2 here, and it rose. So pi over 4, that will be 45 degrees, and the body got rotated. Okay, make it bigger to where we can see. So this is an x-axis relative to the actual body, and it's only for disks that it's shown. On the appearance, window appearance, I can have the option to show their center mass, this symbol, show name, and I can edit this name. It might not work, some of these functions might not work in the newer version of the software. You'll recognize here an additional element like a rectangle with rounded ends. This is an older version and apparently more stable. Okay, and then the other elements that we will be using frequently are rectangles. These two have center of mass at the geometric center. The x-axis, the way I generated the link by dragging horizontally, the x-axis is this way. For this link, the center of mass, of course, is the geometric center, but the center mass. X-axis is transverse rather than longitudinal. So you need to be careful not to create elements by dragging down. If you want to record, measure their angle. If I'm to make this horizontal with the pi over 2 angle, initial angle, yeah, I do have it in a horizontal position. No apparent difference between the two. But if I'm to plot the position as they move of this and this one, there will be a phase difference of 90 degrees or pi over 2 between them. So remember, always create the elements by dragging horizontally. There are squares. I can always replace a square with a rectangle that it has equal height and width values. There are an enter key to close it. There are polygons. And for this one too, I have a center of mass, and there is an orientation for this one too. It's not apparent. You need to keep track of what you're doing. So here, if I change the angle to pi over 2, okay, yeah, could have generated a polygon, and see the snapping. So now I have two. They look identical, but one for 0 angle of rotation will be like oriented like this. This one will look like it was originally. Okay, so you need to be aware of these differences. And then I have the smoothened polygons, and these two they have orientation and center of mass. I can smoothen this one. I think there's a way where I can take a polygon and make it curved. Okay, so and this one, let's see, can I decurve it? Yeah, I can go back and forth between the shapes. Okay, and the last one is an anchor. So I snap it, and I have the body immobilized relative to the background, the ground link. This can also be achieved with this the rigid joint locks two bodies together. So I'm locking the background with this polygonal body, or I could lock these two links together. Okay, by default this is the vertical plane. I have gravity acting, so if you hit run, they'll fall, and you could even see there was the difference between the anchor and the locked joint is that I need to do something else in order to move this around. That is, use the split function, take the half joint, rigid joint to the ground, and then join it to the new location. And this has the rigid joint has additional functions. I just wanted to say that there is an equivalent and address the anchor, which is together with the bodies. There is an orientation tool, so I can click on the mouse cursor, I can move them. There's also a interactive rotation tool, and you need this one, this tool, to align bodies, bring them in close to their jointed configuration when you want to form mechanisms. Okay, so I'm now going to show how to create a 4-bar. So I start by creating the links, and of course click and drag, that's one thing, but serious simulation you need to watch their geometry. Okay, so link length, the first link I'm looking here, it's the W dimension will be 2, and I have the first link, and I could paste it, and I could make it longer. So this will, let's say, will be 5, and then or I can create a body new. So I have 3 bodies. The fourth one will be or first one is the ground. Okay, and I bring it to where it's at. I'm looking here, 1.05. I make this 1, and y was 0. Then the center of mass is at 1 and 0. It means that this end is at origin, and I could snap a motor. Okay, I hit run, and of course I have gravity acting. 2 are falling, this one is rotating. You go to world gravity, and you can turn the gravity off, and now it's like having everything in a horizontal plane rather than a vertical plane. Everything has properties. So if you click on the motor and you go to properties, you will see it's of the type velocities. Other types available are torque or rotation, and torque would be Newton meters value, rotation in radians, and velocity radians per second. So if it's rotation in 0 radians, of course nothing will happen. If I want this to rotate, rather properties, window properties, then I can define a say angular velocity in radians per second, so 10 radians per second times t, and now it's going to rotate. You see it in too few intermediate positions. You can go to accuracy and you can increase the number of simulation frames 10 times. I added a 0. All right. So I have the rotating crank. I'm using the half joints. So as you mouse over, read what it's shown on the corner, left corner, explanation of what each is. So this is point element, this is a square point element, this is a slot, horizontal, vertical slot, curved slot, open, curved slot, closed. If I put together one of that is a point element and a slot element, I will get one of these. Of course, they need to belong to different bodies, and it's what I'm going to do now. I'm going to take a point element and see the snap points, this geometric center, the middle, above and below, and the ends and the corners. So half a pin joint, and then another half a pin joint. And well, this is the problem with the motors that are displacement type, rotation type. So I joined them, and I have the coupler. I need to know where the other ground joint is, and let's assume is like here or maybe here. And then I take this one, and I need to be careful. If I place it here and I join them, it might be a difference. So I'm always consistent in the because I want to measure angles at some point. Now, so I have the two half joints. One was on the ground, one was on this link. This is the rocker. I hold down the shift key and keep it pressed, and then highlight both, and I hit join. So I have the two bodies together, and it's apparent that I'm not going to be able to join this. So if I make it 4, not even, let me make this longer, 5.5. Haven't practiced this earlier, or maybe it could have allowed us to connect them. Anyway, so I'm doing the last step to join the 4 bar, and so I hold the shift key again. Both are highlighted, and I click on the join option, and now I have the 4 bar with all links connected. All right, so the type of input again was rotation, and it's the way I define. I used formula language. So 10, if I have radians, then this will be radians per second times time, t, so it's equivalent to the crank rotating 10 radians per second. There are options. Actually, it goes to numbers and units. Okay, view numbers and units, and from more choices. And from here, you can select distances. In other units, you can go to English, pounds, slugs, and you can model planets. You can see astronomical. You can model at the atomic scale. So it could be either English pounds English slugs, SI degrees, SI radians. So distance for SI meters, and then you can override this. You can change from radians to degrees if you want to. And usually this is recommended to be done at the very beginning. The things that I may be interested in is to plot, and this is the measure, and I have a link selected. If nothing is selected and I go to measure, options are fewer. But I click on this link, and anything that can be measured about this link are available as options here. So I want to plot the position. If I choose X graph, it's going to show as function of time how the center of mass varies relative to the x-axis. Likewise for Y, rotational graph. So we want to measure the rotation of the rectangle as function of time. Okay, and there you have it. There are options here. So again, everything has meter windows have properties, have appearance, and have geometries. So from here, for example, I can position the window, the meter window, and then I can edit the width and height accurately. If I want to have multiple graphs that are click or control carefully their size. I can copy and I can paste. Edit, paste. That was for, I had something else selected. So I edit, copy, edit, paste, and I have a second identical graph. If you're to inspect the database of the model, so you go to properties, and there is a list here. So I'm moving the list, and I start seeing what? Rectangle, and it gets highlighted, as I scroll down. Motor pin, and I have 2 meters, and they're numbered. So there's body 1, 2, and 3. 0.4, 5, 7, 8, 10, 11, 13. See, it's not quite in successive order. And then I have the 2 outputs, but one is number 16. The one is number 17. Okay, and I did the copy and paste for links. For example, when you inspect the properties of a meter of a graph, you will see here T. The x-axis is T time, and it's in seconds. You have the option to show units, so units on and off, labels on and off, frame, yeah, and then the X and Y axis doesn't. They're there. You could see they got turned on. The difference is when it's the X or the Y value rather goes negative, and in this case it will appear below. So I could say, for example, I could translate. I can add equations. So I can translate this minus pi, and if I hit run, then everything is below the x-axis. I added pi to the graph. You can edit the limits. So instead of making this auto, I say simulation, or the plot is no longer going to continue after 2 seconds. And then I could also freeze this and edit the limits. I'm looking, so everything that's between -4 and 0, or if it's between -4 and 0, and this is not auto, the auto is not checked, then I'm seeing only 3 cycles, although if I stop at 1, it's more than enough because I see the one full cycle, and that's it. I can analyze. Another thing that you could make use of is to use the pause control, and you have new condition, and you can pause the simulation, loop the simulation. So I can loop the simulation when time is equal to 1, and sometimes, and you can see that the discontinuous motion because it's looping when time equals 1. Okay, so that was one. I could track. I go to appearance, show center of mass, and then track center of mass. Well, what it does is not quite what I wanted to get. So now it's tracking everything, and then there's the option of tracking. So track every 4th frame, every 8th frame, and there is also here view erase track. What is it? We're tracking erase track. But if you want to track only the center of mass of this body, you go to appearance and you start. So I have track outline, track center of mass. This is the one that I want to track just center of mass, and then rectangle. I don't want to track the outline. I don't want to track the motor. I don't want to track the pin. I don't want to track this pin. I don't want to track this other pin. Base point. Point. I don't want to track. What are these points? These are the half joints that we introduced. Even if you use the instead of the half joints and you connect them with joint, and you use these instead, they are going to be made of these kind of entities. So when you snap one of these, it automatically creates a slot in a pin. Okay, so let's take off all that's tracking. I think there's one that we skipped. Okay. Alright, so now if you hit run, nothing happens. Well, let's go again to this window, appearance, track connect. See the difference. Alright, so we're tracking the center of mass of the link. I could track a point, so I'm placing a point, and if you click, it's still active. You look at properties, and it says the global coordinates. So if you read the global coordinates, it will be between 2 and 3, closer to 3, yes, and on the y-axis is 0.6. Makes sense. Here you read the coordinates in the reference frame attached to body, to the respective body 2. So think of a reference frame with the x-axis along the link, the origin at 0, and y-axis this way. So I have a negative x local coordinate and slightly positive y coordinate. Again, this is in a reference frame attached to the moving body. Okay, and if I want to now window appearance and I want to track connect, let's see what it's doing. So again, I have this by window appearance, track connect. Racetrack. I sometimes manage to, sometimes it doesn't work. In terms of behavior, I think it's possible to connect the location, the location of the points as the mechanism moves. You can leave with just discrete points rather than connected. You increase number of frames per second, and it gets you the locus of the point. All right. So anything else would be for you to research the menu. For example, I can define, I clicked on this body, I can define vector the velocity, and it will be the velocity of the center of mass, or maybe acceleration. And acceleration is too big. Okay, so what you could do, you go back here, define in vector length, and acceleration, we said I can make it 100 times smaller. Let's see the difference. Racetrack, see what it does. Okay, so I have the acceleration vector. In tracking, there's no way of for the acceleration vector. Let's see, is it anywhere? No. So the acceleration vector, you cannot control to track it. It tracks it automatically, inherits the property of the body. So tracking off, now it's showing maybe too small. So I go back to measure, rather define vector length, and acceleration, I can make it 5 times bigger. Okay, and it shows the magnitude of it. The graph, the meter, you can show it as values that change. You can show it as a bar that changes length as magnitude changes. And I said everything has a parent, so I can take the title off. Show name, if you want. Okay, so there are more options. New, for example, define new menu button, and instead of searching for the erase track option, I just have an erase track button here. So, well, window parents track, or what was it? No, I need to turn the tracking on every 8 frames, we said, and I hit the created erase track menu button, and they disappear. The software does also impact and dynamic load analysis. Again, new simulation. Remember to save. It's what I didn't, so save your work. In case it crashes, you don't need to start from the very beginning. So what I'm doing, I'm defining the ground, gravity is acting, and I have a ball that is falling and impacting. Now I could select both bodies and go to properties and change their coefficient of restitution. So if I change this in friction, static and kinetic friction, I can make the static friction bigger. Won't see any difference. Actually here, because it's just dropping, friction does not have an effect. With fully elastic impact, it comes back to its original height. Okay, I can define an initial horizontal velocity, say 1 meter per second. Again, I should have, what are these units? The default, I just started clicking, but the rigorous simulation would start with choosing the units, knowing what these are. Are they feet? Are they miles? Are they is it miles an option? Yeah, miles. Okay, so I have an initial velocity, and I can define, remember, define velocity, velocity vector, define vector velocity, and I hit run, and it's bouncing. As you can see, I can make the vector length a little bit bigger for velocity. I can make it 2.5 times bigger. Okay, and I can increase further increase the simulation. So it was 0.1 to 5.01, like almost 10 times more animation or simulation frames. Actually, never saved it. I should have clicked. So for this one, you need to confirm. So it never happened. What I intended to do. It's only by clicking OK. On other like properties and appearance, if you just close the window, it applies the changes. Here, I need to confirm it. So it wasn't confirmed already. And now it's and maybe even accuracy. Looks like if I make it even higher accuracy, you can observe the impact, reversing the velocity. I can show the force. So define vector force, contact force. Okay, and there will be a contact force that's created by the software when there's I haven't even had the chance to see it, but it's there. Or rather need to define vectors. I said vector contact force. Yeah, it's defined. Need to go to vector length, and for forces, maybe if I make this 10 times bigger, maybe it'll show. So velocity increases, the horizontal component. I want to show something, and it's so maybe it was added accuracy, but this will be too lengthy simulation. It's taking a while. Time to tell a good joke. But yeah, we'll show the. Let me do this. So if I bring them in contact, like so, the contact force will show as a vector. It should show as a vector, and that's I started saying that's introduced by the software automatically to said vector velocity, total force, contact force, maybe now, to repel, to simulate impact. So when the distance between two bodies become too small, it's that contact force that's introduced, and I don't seem to be able to show it. Vector length force, how big it should be. Even at rest, for simulations that I did, you could have seen the contact force. No, maybe with other occasion I'll refine it. Okay, so another option that you have, and I'm recommending it too, we can go back to the previous simulation. I'm not saving this. So remember to do this and do not collide. So if there was some overlap here and it went over it, but otherwise, so for some reason it allowed it. But you could have mechanisms that you see a warning, and simulation cannot be generated, or you cannot do the simulation because the body's contact. Okay. I'm sure you'll be able to decipher and learn about the other options, many options here, and I'm going to stop here. Thanks for watching.